Good day and welcome to VSH Tech Studies. Want to master C loop questions for interviews? In this video, we'll break down the for, while and do while loops using simple flowcharts and the real output tracing. We'll also cover prerequisites regarding division and mod operation. Then we will solve 3 smart loop-based C questions step by step that can sharpen your logic interview style. Let's start the session. First, we shall know how many loops are there in C. There are 3 loops in C programming. They are first one for loop, second one while loop, third one do while loop. So next with structure and flowchart of loops, we can get to know the working of them. First one, let us take a for loop. The structure of for loop is as follows. For is the reserved word within bracket. First, the index is initialized. Whether index value is within limits, yes or no, that is checked. If it is true, then from here to here it is loop body, means many instructions will be there or one instruction might be there. So that set of instruction will be executed. After that, this index value is again updated. So next condition is checked. If it is true, loop body is executed. Next, index value is updated. If condition is found to be false, the control will go out of for loop. That is, for loop gets terminated. So diagrammatic representation of the working of for loop, that is flowchart, which is given here. First, index value is initialized. Whether it is within limits, condition is checked. If it is true, loop body is executed. Index value is updated. Then again it will go back to check the condition. If it is true, again execute loop body, update the index value. So this control will be within loop only. Suppose if condition is false, then only the control will go out of loop, that is loop gets terminated. Okay. Next we'll see to structure and flowchart of while loop. While is the reserved word. So test condition is specified in the structure here. If it is true, so whatever within this begin and end flower brackets, that loop body set of instructions, that will be executed. If condition is false, the control will go out of loop, that is loop gets terminated. So in while loop, first the condition is checked. Only if it is true, the loop body is executed. Otherwise, it will go out of loop body. So it will be there in the loop body as long as condition is true. So because condition is checked at the beginning, the loop may not be executed at all if it is found to be false. So the loop body may get executed even for 0 times, means not at all executed. Next, if you see to do while loop structure here, do is the reserved word, while is the reserved word. From here to here it is a loop body. So set of instructions will be specified there. While in bracket here condition is given. If it is satisfied, then only the loop body will be executed. If it is not satisfied, the control will go out of loop. That is loop gets terminated. So here first the loop body is executed, then the condition is checked. If it is true, then again loop body is executed. So the control will be within loop as long as test condition is true. If it is false, then it will go out of the loop and loop gets terminated. So one thing to be observed here is, so the loop body, because it is executed in the beginning, to the minimum it will be executed at least once, because after execution of loop body, condition is checked here. So this is what is the difference between do while and while loop. So in while loop, first condition is checked. Hence if it is false, the loop body may be executed to the minimum even for 0 times. But in do while, because first loop body is executed to the minimum, it will be executed at least once. So when for loop is used when we know exactly how many times the loop has to be executed. Okay. When while loop is used when we need loop body to be executed only if condition is satisfied. Otherwise, not at all. The loop body must be executed means it may be executed to the minimum even 0 times. It may not be executed at all. When do while loop is used? Do while loop is used when we want the loop body to be executed at least one time. Next, if condition is satisfied, only the control will be inside the loop, otherwise it will be going out of the loop, that is loop gets terminated. Okay. Next, let us see to some prerequisites needed to trace the programs and write the output in today's session. Okay. Int a means a memory location by name a is reserved. So next instruction, if a equal to 18 divided by 10 means what will be stored in a. So 18 divided by 10 means 18 is taken divided by 10. So 10 ones are 10. So 18 minus 10 is 8. We will give point here, again 0. 10 eights are 80. So what is the answer here? 1.8. So that 1.8 must be saved in a. But a is integer type, so this 0.8 cannot be saved. It will be saving only integer part and hence a will be 1. Okay. So that is what is the output of this single statement. A equal to 18 divided by 10 means a will be having 1. Okay. Now we'll take up this instruction, a equal to 1 divided by 10. So 1 divided by 10 means 10 zeros are 0. So 1 minus 0 here. So next point is kept here, 0 is borrowed. So 10 ones are 10. So 0.1 is the answer, 0.1. So this must be assigned to a now. But a is integer type, it cannot store 0.1, that decimal part, it will be storing only integer part, a will become 0. So the output of this statement is a will be having 0. Okay. So after completing these division operations, let us consider this mod operation. A equal to 18 mod 10. Mod operation means we will have to take the remainder. 18 mod 10 means divide 18 by 10. So 10 ones are 10. So 8 is the remainder here. So 8 remainder will be saved in A, because the output of that has to be saved in A. At the end of this instruction execution, 8 will be saved in A. Okay. Next we'll see to this fourth instruction, a equal to 1 mod 10. 1 mod 10 means divide 1 by 10, then take the remainder. So 1 cannot be divided, so here 10 zeros are 0, 1 minus 0 is 1, so the remainder is 1. So remainder is 1, that must be saved in a, means in a 1 is saved. Okay. So what is the status of a after this instruction? 1. So after this instruction a is 0. After this instruction a will become 8. So after this a will become 1. Okay. So this prerequisite is needed for tracing and writing the output in this session. Now let us start solving the questions. The first question, what is the output? So in all the questions we'll have to write the output for given C programs. Okay, here preprocessor directive, main function is here. So from here to here it is the main function body. So whatever instructions are there inside main function body, they will be executed one by one. So the first statement is declaration statement, that is memory locations are reserved. So integer type data is to be stored. So I is the one memory location that is reserved here. Then A is another memory location. In that 1 is stored, means A is initialized with the value 1. So then B is another memory location. There it is initialized with the value of 5. So assigning the values to variables, so this I, A, B, the names of memory locations, they are called as variables because the different values can be stored in those memory locations. Assigning the value during the declaration to the variable, that is called as initialization. Next we have for loop statement. So from here to here it is for loop body. So how many statements are there in the for loop body? So printf is one statement. So this if else is together it is second statement. So how many statements are there? One printf and one if else. Two statements are there. So when more than one statements are there, we have to give begin and end flower brackets. If only one is there, we need not give begin and end flower brackets. That single statement following for loop will belong to that for loop statement. Okay. Now we'll trace this for loop. So I equal to A. That is I is made. A means in I memory location what A is there. So that is stored here. So I is made as A means I is also made 1. Next condition has to be checked. Is I less than or equal to B? So I is 1 here. Is 1 less than or equal to B? B means how much here? That is 5. Okay. So is 1 less than or equal to 5? It is true. Then from here to here this loop body has to be executed. Means two instructions one by one they must be executed. So what is the first statement? Printf statement. So it will write something on the monitor. What? Integer value. So integer value is written. Then space is left. Okay. So what value will be written here? So that is taken outside double quotes. What is there? I. So what is there in I? So 1 is there. So 1 will be printed. Space will be left. Then control will come and stand here. So this is the status of execution of first instruction. Next instruction is if I mod 2 equal to 0. That has to be checked. Is I mod 2 is 0. That is 1 mod 2 0. So 1 mod 2 is not 0. It is 1. So this will not be executed. This is false because this condition is false means this true block will not be executed. The control will go to false block. So what is written there? Printf odd. So then leave the line. So odd where the control was left here on the monitor, here odd is printed. So that is printed. New line means the control will go to next line and it will stand at the first position. So one iteration is over now. Next control will go back to again for loop. So when control comes back to for loop, so I plus plus is done. I was 1, now it is made 2. Next condition has to be checked. Is 2 less than or equal to 5? Yes. Then inside loop body whatever instructions are there, they will be executed. So first printf %di, integer value that is I. How much it is? 2. So the control was left here, 2 is printed. Then space has to be left. So the control will be standing here. So then if statement I mod 2, I is 2. So is 2 mod 2 0? Yes, true block works then. Printf, what it prints? Even, then leave the line. So here even is printed, then leave the line means it goes to next line and stands in the first position. Okay. So this is second iteration or second time execution of the loop body. Next control comes back to for loop. Now I value is incremented. So it was 2, now it is made 3. Is 3 less than or equal to 5 means is 3 less than or equal to B means it is 5. So B is 5. Yes, 3 is less than or equal to 5. Then inside loop body first instruction, it is print the integer value of I. I is 3. So here in this position 3 is printed. So it has to leave the space. Then control will stand here. Next if statement. I mod 2. I is 3. 3 mod 2. Is it equal to 0? No. 3 mod 2 is 1. So this is true block will not be executed because condition is false. it goes to false block. There printf odd. So odd should be printed and leave the line. So control was here, odd is printed and leave the line means it goes and stands in the next line in the first position. Next control comes back to for loop. I is incremented, so it is made 4. 4 is less than or equal to 5. It is true, it will come inside the loop body. So printf is executed. So integer value of I is 4. So 4 is printed, space is left. Then if statement, so 4 mod 2, is it 0? 4 mod 2 is 0. Hence it is true means true block will be executed. Here even is written. Then after that leave the line means go to next line. So stand in the first position. Next control will come back to for loop. I value is incremented. So it is made 5. Is 5 less than or equal to, that B means 5 because B is 5. Yes, it is true because 5 equal to 5. Then control comes inside the loop body here. Okay. So first instruction print integer value of I. So integer value of I means here I is 5. So 5 is printed, space is left. Then 5 mod 2, is it 0? No. So true block will not be executed. It will come here. So odd is printed and leave the line. So after printing 5 and leaving space, odd is printed, leave the line and control waits in the next line. So the output on the screen is this. What is printed? 1 odd, 2 even, 3 odd, 4 even, 5 odd. Because next I value becomes 6. 6 is not less than or equal to 5. The control had gone out of loop. Okay. So let's answer one extra question here. How many times for loop gets executed? So initialization, if you take I is A means I is 1. So I is initialized to 1 because A is 1 here. So then condition has to be checked. Is I less than or equal to B means it is 5. B is 5. So then because I is 1, so the loop gets executed. Then I is incremented. It is made 2. Is 2 less than or equal to 5, again executed. Then I is incremented. It is made 3. So 3 less than or equal to 5, okay, true. So loop body gets executed. Then I is incremented. So it is made 4. Is 4 less than or equal to 5, yes, again loop body gets executed. Next I is incremented means this I is made 5. So is 5 less than or equal to 5, that condition is checked. So true. So again loop body gets executed. Next I is incremented. So I is made this time 6. Okay. Is 6 less than or equal to 5? So this condition that fails. So the control goes out of loop body means next instruction outside the loop body. So from here it was start and this end of loop body. So go to next instruction outside the loop body means loop execution gets terminated. Their end of program. Hence, as per logic involved in the loop body, we have got this output on screen, and when it is 6, I is 6, it doesn't get executed as long as I is 1 to 5. So means 5 times the loop body gets executed. So how many iterations are there or repetitions of loop body execution is there? That is 5 times. Okay. So next we shall move on to second question. So in second question, here we have declaration. So A memory location is initialized with 1, 2, 3, 4, 5, 6. Then one more memory location, yes, is initialized with 0. So the third memory location is D. Okay. So after this declaration we have while loop statement. The condition here is A not equal to 0. That condition has to be checked. A means 1, 2, 3, 4, 5, 6. Is it not equal to 0? Yes, it is not equal to 0. The condition is true. Hence this loop body must be executed. So from here to here it is loop body. How many instructions are there? 3 instructions are there. So the first one, D equal to, so this D equal to A mod 10. So A is 1 2 3 4 5 6 mod 10. This is D. So then when you divide this by 10, the remainder is 6, that is assigned to D. So D will be 6. Next, S is equal to S plus D. S equal to S plus 0 plus D means 0 plus 6. 0 plus 6 is 6, that must be saved in S. So this 0 is taken out and S is made 6. The third one is A equal to A divided by 10. So A 1 2 3 4 5 6 divided by 10 means 1 2 3 4 5 0.6. Because A is integer, 0.6 is not saved. Only integer part will be saved and hence A will be 1 2 3 4 5. So one iteration is over because 3 instructions are over. So the end of while loop body. So the control has to go back to next iteration of while loop. So at the end of first iteration, A is 1 2 3 4 5, S is 6, D is 6. Okay. So in next iteration of while loop, A condition is checked. A not equal to 0. 1 2 3 4 5 not equal to 0. Correct, it is true. Hence loop body must be executed. The first statement, D equal to A mod 10. So 1 2 3 4 5 mod 10. So 1 2 3 4 5 mod 10 means divide this by 10, the remainder is 5, that must be assigned to D. So now D is made as 5. The second statement, S equal to S plus D. So S equal to S plus 6 plus D means 5. 6 plus 5 is 11 and hence S is made 11. The third one, A equal to A divided by 10. So in A we have 1, 2, 3, 4, 5. Divided by 10 means 1, 2, 3, 4, 5. 0.5. 0.5 cannot be stored. Only 1, 2, 3, 4 is stored in A because A is integer type. So the 3 instructions are over. So the control has to go back to next iteration. At the end of this previous iteration, what is the status? A equal to 1, 2, 3, 4. S equal to 11. D equal to 5. In the next iteration, A condition is checked. A not equal to 0. A is 1, 2, 3, 4. It is not equal to 0 is true. So loop body must be executed. In that first instruction, D equal to A mod 10. So A is 1, 2, 3, 4. Mod 10 means remainder. After dividing this by 10, the remainder is 4. So that must be assigned to D. So D, this is 5 is taken and this is made as 4 now. So next second statement, S equal to S plus D. S equal to S plus 11 plus D means 4. So now S is made 15 because 11 plus 4 is 15. Next third instruction, A equal to A divided by 10. So A is 1, 2, 3, 4 divided by 10 means 123.4. So this 0.4 is taken out, only 123 is saved because A is integer type. So all the 3 instructions are over. The control has to go back for next iteration. At the end of previous iteration, A is 123, S equal to 15, D equal to 4. So this D equal to 4 we shall keep here. So in next iteration, A is not equal to 0. It is checked. 123 not equal to 0. Yes, it is true. So next loop body has to be executed. In that first instruction, D equal to A mod 10. So A is 123 mod 10. So after dividing this by 10, the remainder is 3, that must be assigned to D. So D instead of 4 now it is made 3. So second instruction, S equal to S plus D. S is 15, D is 3. So 18 is saved in S. So S is made 18. Next, third instruction, a equal to a divided by 10. So a is a divided by 123 divided by 10 means 12.3. So 0.3 cannot be saved, only 12 is saved. Now all the three instructions are over. So at the end of this iteration, a is 12, S is 18, D is 3. So now control will go back for the next iteration. In next iteration of while loop, a not equal to 0. This condition has to be checked. A is 12. 12 not equal to 0 is true because 12 is not equal to 0. Then loop body must be executed. The first statement, D equal to A mod 10, that is 12 mod 10. After dividing 12 by 10, the remainder is 2. So that must be saved in D. So in D, 2 is saved. So next instruction, S is equal to S plus D. S equal to S. S is 18 plus D, that is 2. So 20. 20 must be saved in S. So in S, 20 is saved. The third instruction, A is A divided by 10. A means here 12. Divided by 10 means 1.2. This 2 cannot be saved, only 1. So all the three instructions are over. At the end of this iteration, A is 1, S is 20, D is 2. So the control will go back to next iteration next. In the next iteration, A not equal to 0, A is 1. 1 not equal to 0 is true, hence loop body must be executed. First instruction is, so D equal to A mod 10. So 1 mod 10 because A is 1. So 1 mod 10 is 1 only. So that must be assigned to D. So in D, 1 is saved now. Second instruction, S equal to S plus. S is 20 plus D means 1. So 21. That must be saved back to S. So S is made 21. The third instruction, A is A divided by 10. A divided by 10 means 1 divided by 10. 1 divided by 10 is 0.1. So 0.1 cannot be saved. This 0 integer part is saved. So A is made 0 now. Okay. So all the three instructions are over. This iteration is over. So next control will go to next iteration. So at the end of this previous iteration, A is 0, S equal to 21, D equal to 1. So in next iteration, check the condition, A not equal to 0. A is how much? 0. 0 not equal to 0. It is false. 0 equal to 0. Not equal to 0 is false. So now this loop body will not be executed. So because this condition is false, the control will go out of loop means here loop begin, loop end. Out of this means here. So the control will go out of loop body to next statement. Here what is the statement? Printf. So on the monitor something must be printed. What is printed within double quotes? S equal to as it is. Percentage D means integer value from S. From S means 21, that is printed. Then leave the line. Leave the line means it will stand here. So output on the screen is S equal to 21. Okay. So if you observe the output here, that is S equal to 21, the 21 is the sum of all the digits in the number A. Okay. So if you give any number here, so this program is going to find the sum of all the digits in that number. Okay. Next we'll solve third question. In the main function, first we have declaration statement. So int means integer type. So a memory location is taken. In that we can store integer data. So a memory location is initialized with 892 means in that memory 892 is stored. Next another memory location is reserved by name D. Next we have do while loop. Then this is the loop body. There 1, 2, 3 instructions are there. these will be executed during start, because do will not check the condition first. So after executing these three once, then the condition will be checked. If this condition is satisfied, only then control will go back to again execution of loop. Okay. So then after this the control will go to execution of do while loop. So this is loop body start and it ends here. The first instruction is taken, D equal to A mod 10. A is 892 mod 10. So when 892 is divided by 10, the remainder is 2. So that will be assigned to D. Hence in D 2 will be saved. Next statement is printf, means something on the monitor is printed. What is printed? Integer value from D. So from D integer value means 2 will be printed. Next space is left. The control will come and stand here. Next third instruction, A equal to A divided by 10. A is 892 divided by 10 means it is 89.2. So that must be assigned to A, but it cannot store 0.2 because it is integer type. So only 89 will be saved in A. So 892 is striked off, 89 will be saved in A. So the execution of all the three instructions in the loop body is over. Now condition will be checked. While A is not equal to 0, A is 89. It is not equal to 0 is true. So next control will again go back to do while loop execution. Okay. So at the end of first iteration, A is 89, D is 2, and on the monitor 2 space is printed, control is standing next. Okay. So in the next iteration, from here to here, these three instructions are to be executed. So the first one, D equal to A mod 10. A is 89. Mod 10 means 89 divided by 10. When you do, the remainder is 9. That will be assigned to D. Now this 2 is taken out. 9 will be saved in D. Okay. So the next statement is printf integer value from D. So that integer value from D means 9 is printed here and space has to be left. Space will be left. Control will stand here. So the next statement is A equal to A divided by 10. A is 89 divided by 10. It will be 8.9. This must be assigned to A, but 0.9 cannot be assigned because A is integer type. So only 8 will be saved in A. So now this 89 is taken out. Only 8 will be saved in A. Next, this condition is checked. A not equal to 0. If it is true, A is 8. It is not equal to 0. So it is true. Again control will go back to execution of do while loop. Okay. So in the next iteration, the first statement is taken, D equal to A mod 10 means A is 8. So 8 mod 10. So when 8 is divided by 10, the remainder is 8 only. So that is assigned to D. So from D, 9 is taken out and 8 is saved in D. Second instruction, printf integer value from D. So this is printed here. It was left here and space is left. The control will stand here. The third instruction is A equal to A divided by 10. A is 8 divided by 10 is 0.8. That must be assigned to A. This 0.8 cannot be saved and hence only 0 is saved because A is integer. So here 8 is taken out and 0 is saved in A. So after these three instruction execution, the condition is checked. A is not equal to 0. So A is 0. A is not equal to 0 is false now. Hence the control will not go back to execution of do while loop. So it goes out of loop means that is next statement, that is program end. Hence on the monitor we have 2 space 9 space 8 printed. So this is the output. So if you observe the output, A is 892, the output is 298. So here the number in A is just written in reverse order on the screen. So any number you give here, that will be printed in reverse order in this program. Okay. With that, we come to the end of our deep dive into loop-based C interview questions. We covered for, while and do while loops with flowcharts, outputs and logic. Got any doubt or you solved it differently? Drop it in the comments. If you find the video helpful, don't forget to like, share and subscribe at VSH Tech Studies for more practical C programming content. Hit the bell icon so you never miss an update. Thanks for watching and see you in the next one.